Alrighty guys, we're going to go ahead and get started with these series examples. And the first one we have up here is telling us to draw a circuit with 4 resistors. And that's a series circuit. And just a reminder, when we say series circuit, what does that mean? Well, that means that there is just one path to the battery. So we start at one end and we come back to one end, and there's only one complete path around that circuit. So if I start off with my battery over here, I got my battery, I got my wire coming off. Here's my first resistor, here's my second resistor, here's my third resistor, and here's my fourth resistor. Okay, so here's an example of what a series circuit could look like. Again, I have one path, so if I start right here at my battery, I go up and over, and I cross every single resistor. How do I know this is series? Well, if one of these resistors goes out, what's going to happen? Well, all of them are going to stop working because there's only one path. Let's take a look at number 2 over here. If the series resistors are as follows, 10, 20, 40, and 60 ohms, what is the total resistance of this current? Well, it told us that this is series, and in series, we know that the total resistance is just equal to the resistance of each resistor added up together. So R1 plus R2 plus R3 plus R4. In this case, I know that R1 is 10, R2 is 20, R3 is 40, and R4 is 60. So if I add all these up, I end up with 130 ohms. Now let's move to number 3. Based on our square of love, what is the same throughout this circuit? So for a series circuit, what is consistent? What is always the same? Well, let's go back and take a look at this up here. And if we look at this circuit up here, which is a series circuit, like we said before, because there's one path, we're going to notice that if I start with some amount of energy at my battery, so energy meaning the voltage, right? Is that going to be the same everywhere inside this circuit? Well, let's pretend that that energy is like a plate of food. So over here, we're starting with a lot of food. It's Thanksgiving dinner. Your whole family shows up, and you start with a bunch of food at the top of the table. I take that food, and now I pass it along the table. My cousins, my aunts, my uncles, everybody takes a little bit of food off that tray, and then eventually it reaches me over here. Is that tray still going to be full of food? No. That tray is no longer full of food. It has less food than when I started. Therefore, the voltage or the energy is going to be different at every point in a series circuit. So this is not our answer. Resistance, well, we just said the total resistance is us adding these up. So that's not the same either. So our answer is current, meaning that the speed of those electrons and how fast they're moving throughout the circuit is going to be the same everywhere inside a series circuit. And that's because there's only one path for those electrons to go down. Number 4, a series circuit consists of a 12-volt battery and 2 4-ohm resistors. V equals IR. Complete the square of love and draw a picture. So this is a series circuit, so we know that we need a battery here because we have a 12-volt battery. And then we need 2 resistors. So here's one resistor, and here's my next resistor. I'm going to go ahead and label on my picture so I know what's going on. So 12 volts here, and then this is 4 ohms, and this is 4 ohms. Now that I have my picture drawn out, I can go ahead and solve. So I want to start filling out my table down here. It told me that R1 and R2 are both 4 ohms, so I'm going to write that here, 4 and 4. It also told me that the voltage of the battery is 12 volts, so the total, that's referring to the battery, and I can go ahead and put 12 volts here. Next, I want to start using what I know to fill out the remaining boxes. I know that in a series circuit, that resistance is the sum of all the resistors. So 4 plus 4, that means 8. So my total resistance here is 8. Next, I need to solve for current because the only way that I can figure some of these out is if I'm only missing one variable. And by one variable, we mean one box. So let's remember V equals I times R. Well, V in this case is 12, I is what we're solving for, and R is 8. So if I solve for I find out that I is equal to 12 over 8, which is just 1.5. Like we said above, in a series circuit, current is the same everywhere. So the total current is 1.5, and the current through resistor 2 is 1.5, and the current through resistor 1 is 1.5. Now that I know the currents, I can solve for voltage. Voltage is equal to current times resistance. So 1.5 times 4, that's going to give me 6. 1.5 times 4, that's going to give me 6. How do I know if the voltage is correct? Well, in a series circuit, the total voltage should be equal to each of the individual voltages added up together. So if I do that really quick, I find out that 6 plus 6 is equal to 12, meaning that my voltage is correct. And this one is done. Let's take a look at number 5 over here. Number 5 says a series circuit consists of 2 resistors that total up to 10 ohms of total resistance. The voltage through the first resistor is 4.2 volts, while the voltage through the second resistor is 9.8. Complete the circuit, complete the square of love, and draw a picture. So here is our battery, and then here's our 2 resistors. We know that it's in series, so it looks something like this. Unfortunately, we don't have any values for these specific components yet, but we do have values for our table down below. It told us that the series circuit consists of 2 resistors that total up to 10 ohms. So my total over here is going to be 10. It also told me that the voltage through the first resistor is 4.2. So this should be 4.2. And then it also told me that the voltage through the second resistor is 9.8. Okay, so I'm missing a lot of stuff here, but fortunately I know what my series circuit rules are, and I remember that the total voltage is just equal to the 2 voltages added up. So V1 plus V2, so that's 4.2 plus 9.8. That's going to give me a voltage of 14. Now that I have this, I'm just missing current here. I can go ahead and solve for total current. Well, voltage is equal to current times resistance. That's another equation. Therefore, I get 14 equals current times 10. I solve for current, and I find out that current is equal to 14 over 10. If I simplify it, that's just 1.4. Another property of series circuits, like we mentioned before, is that current is the same everywhere. So the current through R2 is 1.4, and the current through R1 is 1.4. Lastly, I solve for resistance here. So first I'll solve for R1, V equals IR. So 4.2 is equal to 1.4 times R. Divide by 1.4. And I find out that the resistance for my first resistor should be 3. Do the same thing for my second resistor over here. I have 9.8 is equal to 1.4 times R. Again, I divide by 1.4. And I find out that this resistor should be 7 ohms. How do I know I'm right? Well, I can fact check. I told you before that total resistance for series is equal to R1 plus R2. Well, R1 is 3, R2 is 7, 3 plus 7 equals 10. Perfect. All right, now let's take a look at our last problem here. Complete a square law for a series circuit with 4 resistors. The first resistor has a voltage of 15 volts. Go ahead and write that down. The second resistor is 3 ohms. Write that one down. The third resistor is 7. Got that. And it has a current of 5 amps. And the total voltage of our circuit is 75 volts. So we're missing a lot of stuff here, but fortunately we know our circuit rules, so this shouldn't really be that bad, and we should be able to solve it pretty easily. I'm just going to write those rules down one more time in case we forget. First one is that the total voltage is just equal to each of the voltages added together. And we have 4 voltages here, so it should look like this. Next one is that the total current is equal to each current. In other words, the current is the same everywhere inside our circuit. And that's going to help us get started with this one. So let's do that first. I have the current through resistor 3, which is 5. So the current through resistor 2 is 5. The current through resistor 1 is 5. The current through resistor 4 is 5. And the total current is 5 as well. Now I see that I can start solving for this. I'm only missing one box here. I know voltage is equal to current times resistance. So if I solve for the resistance here, that means 75 is equal to 5 times R. Go ahead and divide 5 over, and I find out that the total resistance here should be equal to 15. Next, I can start solving for some of these voltages over here. So if I do it for resistor 2, I know that V is equal to I times R. I is 5, R is 3. So that just means that the voltage here should be 15. Same thing over here. V is equal to I times R. The I is 5, the R is 7. 5 times 7 is 35. Now it's really just preference if we want to solve here or solve down here. I'm going to go ahead and solve for the resistance first up here. And this is going to tell me that voltage equals current times resistance. So 15 equals 5 times R. Solve for R by dividing 5 over to each side. And I find out that the resistance for my first resistor should be 3. Next, I can solve for the voltage for R4. And there's two ways to do that. I could either solve for it directly, or I could solve for resistance first and then use that to find the voltage. Let's solve for voltage directly because I think that that's kind of easy. We know that total voltage is equal to V1 plus V2 plus V3 plus V4. So our total voltage is 75, V1 is 15, V2 is 15, V3 is 35, and V4 is unknown. So if we add all those up, we end up with 75 is equal to 65 plus basically X, our unknown variable. Subtract 65 over, and that tells us that our missing voltage should be 10 volts. Now that we have the missing voltage, we can solve for resistance. Voltage is equal to current times resistance. 10 divided by 5 is just equal to 2. And that's all there is to it.